これで、今、中です。聞こえるようになりましたね。よし。じゃあやっていきますか。あれ、てか。というか、これは追加した方がいいのかな？大きさを大きくしたい。まあ、とりあえず。まあ、ちょっと。意外とさ。It's for yard, but we are. This is a deal. うん。Level diff. As you can say, this cargo unit has created file called card. はい。Defines a function called memory. Function is special. コンパランドランニング。では、ここまでは普通ですね。画面を大きくして。画面を大きくしたいけどできないっぽいからやめた。てか、配信画面の方だと思 解像度が何もわからん状態ですね、これは。どうしよう。どうしようかな。心の目で見てくれとしか言いようがない。あと、ヘクトに関するページ、リンクはあっちに書いてある。動画概要欄の方に書いてます。ちょっと待ってね。あれあれボカンが効いてないぞ。ちょっとリスタートするか。あれ、ラストサーバーが機能してなくね？ラストサーバーが今リローディングラストアナライザー状態なので、なんか適当なターミナルのなんか面白ツールでも入れとくか、この間に。ハリウッドアップデート。それで、あと、インストール。ハリウッド。はワンネンだけど。まあいいや。C。アンラップして、で、これは U8 だけど、これをチャーとして、やって、プリント LN の そのじゃあね。はい。でいきましょうと。ええ動く。フィックスさせたいなど。これどうすりゃいいんだ。これをこれってもしかしてさ、同じウェブページないと。そうなんだ。画面遷移しちゃったらこれ、機能しなくなっちゃうんだ。へえ、不思議。大きさをいじりたいな。大きさいじりたいけどなんかできなさそうだな。まあいいや。どこら辺読んでるかさえ分かればいいだろう。で、まあとりあえずインポート入力に対してバイトで読み込んで、かつバイトに対してアンラップして、それをチャートして読み込んで、それをプリントしてると。で、ここではセルフとリードが必要ですと。IO を使うから、当然セルフが必要で、バイトでリードしてるから、はい。で、アンラップ、これ、リザルト型なのでアンラップします。で、アンラップしてリザルトだったら、return the contained OK value, consuming the self value. ただ、これは、エラー型の時は、まあ、パニックを起こすはず。書いてありますね。はい。てかこれ、そう一旦解除しないと。ちょっとサイズ的に。やば。ちょっとさすがにワイドスいじるか。やべ、全く慣れてね。ライブコーディングって何やるんだよ。after this we have able to use IO in our cloud and bringing plate into our cloud enables us to use bytes. Try running your code without a button because it breaks. If you are new to the that we want to call a method called std はい。まあこれは IOSTD インのスタンダードインの使い方で for in 使ってアンラップアプリだからこんな感じになると。だから、これとかは入るんだ。で、プラス Q to quiet っていうのを次に実装したいと。だから、それについては単純で、ただ、これやると、ブレイクってやると、これやるとさ、テスト Q ってやっちゃうと終わっちゃうんだよ。To quite this program, you have to type a line of text that includes a Q in it and then press enter. だ例えばテスト Q テストってやると、もうテスト Q の段階で、これできる。ブレイクするようになる。A low mode by using terminal。ターミオンってなんだ？ターミオン。わかんないけど、とりあえずカルゴビルドしてターミオンに入れよう。You might notice that. さあ、カルゴドットロックに入ったんで、はい。何やろうとしてたのこれ。Into low mode. Low mode means that the steady standard in won't be printed. It will be in instead have to be written manually. その canonicalized overflow. There are few things to note there. Here, first we are using Termion to provide STD out. The counterpart of STD from up is a function internal mode, which we are calling. But why are we calling that method on STD out to change how we are reading from STD in? The answer is that terminals have their states controlled by the writer, not the reader. The writer is used to draw on the screen or move the cursor, so it is also used to change the mode as well. Second, we are assigning the result of into raw mode to a variable named _stdout. But we are not doing anything with that variable. Why? Because this is our first encounter with Rust's ownership system. To summarize the complex concept, functions can question all certain things. Unowned things will be removed into raw mode, modify the terminals, and return the value which, once it is removed, will reset the terminal into a canonical mode. So we need to keep it around by binding it to _stdout. You can try it. You can try it out by removing let _stdout. The terminal will not stay in raw mode. By prefixing the variable with _, we are actually telling it as reading our unused variable, not prefix with unused variable. So, though the topic of ownership is complex, so let's skip all the serving key presses. 일단 WSL で開発してるとさ、なんか読み込みがさ、遅いんだよ。なんか、リフレッシュされないことがあってさ、マジで、萎えるんだよね。で、何をやるかな。コントロールってなんだ。 ゼネラルカテゴリー。ああ、はい。なるほど。コントロールと呼ばれるようなものを読み込もうとしていると。First, we are no longer only printing the character C, but also bytecode B. ああ、なるほどね。You're wondering about B and Rust. It is perfectly legal to declare a variable. ちょっとサイズ変えるわ。サイズを変えた理由は単純で、使ってるツールで閲覧するようにするため。これトップに戻すやつなんだっけ忘れた。それ見よう。ターミナル。ターミナル。リセットクリア。クリアでいいか。はい。Before we are declaring B first in for B in. And then again with a lock. This is called shadowing, and it is immensely 非常に広大に The first value of B is not useful for us. As we only want to work with the unwrapped value, I propose we will explain that soon. Variable shadowing makes sure we don't have to deal with two variables like B unwrapped and B. Try playing around with this concept by dropping the let B. By the way, the as keyword attempts to transform primitive value into another one, in this case, a byte into a single char. As control tests that whether a character is a control character. Control characters are non-printable characters that we don't have or to print to the screen. ASCII code 0 to 31 are control characters, and 127 is also control character. ASCII code 32 to 126, 21 to 6 are all printable. Printer is a macro which prints its input in a single line. Bracket and bracket question with the argument passed to printer the press resolution. ここら表示。仮レタン。 this carriage. And moves the cursor back to the beginning of the calendar and before printing it at the end. You're right. Which moves the cursor downward line, scrolling the screen if necessary. Okay, press this down right into the characters. Wait. Most ordinary keys turn right directly in character.疲れてる。This is the best. Around.で、プレスコントロールで、ここまでで一度、で、ここまでで一度コミットしとくか。いや、しなくていいな、このボタン。いや、しとくか。Use into draw mode. We know that Control key combined with alphabetic key seems the map. 間違い。コントロールキーが押せないはああ、なるほど。これちょっと面倒だけど、こうせざるを得ないか。理解しました。 あとソースで、はい。で、失礼。で、コントロール Q でホワイトを実装させたいとなりました。で、to control byte で、to control byte に変換する実装をしたいと。まず、to control byte C をchar の U8 に変換します。どうやって変換するか。まず、バイトの C を、U8 に変換します。で、バイトナンバーワン。Think that this whole bitwise proof is too low level for the task. Then you are right. We are doing this now to get a better understanding about the fundamentals, but we will refactor it in the next chapter. To control byte function, bitwise ANDs a character with the value 000 in the binary. If you are interested, you can paint around. To print out the binary representation of variable b, the b in. Try this to see the actual byte which are laid into the program. Printで、Q が、 problem.なるほど。The ASCII character set seems to be designed this way on purpose. It is also similarly designed so that you can set and clear a bit to switch between a lowercase and uppercase. If you are interested to find out which byte it is and what the impact is on combinations such as Ctrl plus A, is contrast to Ctrl Shift A. で、これで Q を押しても大丈夫になったと。It's time to think about how we handle errors once we add a die function that prints an error message that and exists program. これあんま良くねえな。パニックのエラー。Rust does not allow you to add some kind of try-catch block around the code to catch any errors that might occur. Instead, we are propagating errors alongside the function return values, which will allow us to treat errors at a high level. The propagation works so that a function when an error could happen returns. This propagation works so that a function where an error could happen returns something called a result, which is a wraparound result where after every be originally a result, which is a hold OK wrapping the byte may have read in or an error which have lapsed an error object, including that something went wrong while reading the byte. To get the value we need, we can call unwrap, which is short for if we have an OK, returns value, wrapped it in it, panic if we have an error. We want to control the crash of ourselves instead of letting a Rust panic whenever our error gets because later on we want to clear the screen before crashing. Do not leave the user with half-done email. For now, let's simply check for an error and can't die, which panics for us.さっきのアンラップをなくして、式に落とし込んで、そんで、チェックしてるという感じですね。Here, a few more things to observe. We are deliberately ignoring the error from into low mode. ここで本来だったら、エラー起きてるはずなので、当然ここでアンラップしてるから。Our error handling is mainly aimed at avoiding garbled output. グラブルで勝手に歪める。Which can only occur when we are actually repeatedly writing to the screen. So for our purpose, there is no need for any additional error handling before our loop begins. Then we have introduced a new concept match. For now, you can think about match as surprised if-then else, supersized if-then else. It takes the original to code campaign. Or it does if the variable foo is away. That concludes this chapter on entering low mode. We have learned a lot about the timeline and about the fundamental last one. So in the next chapter, we'll do some more terminal input-output handling and use to draw to the screen and allow the user to move the cursor around. We will also refactor our code to be more idiomatic. But first, need to clarify what idiomatic means. はあ、疲れた、ちょっと。関西水美味しい。うん。In this chapter, we will tackle writing home and writing to the terminal. But first, we need to make our card more idiomatically. Beware. The beginning of this chapter will contain a lot of plus. 3 which you can safely skip if you are not interested. クソ長。チャプター3が長いっすね。Whenever you deal with neural language such as Rust, you will often hear about idiomatic code. Apparently, it is not enough to make the code solve the problem. It should be idiomatic as well. Let's discuss first why this makes sense. Since the term idiomatic comes from languages, we start off with our linguistic example. If I told you that with this tutorial, you could kill 2 files with 1 sword, because you learn Rust and write your very own editor at the same time. Would you understand my meaning? If you are a German, you would probably not have any trouble, because killing 2 files with 1 sword is a near literal translation of German saying, if you are Russian, killing 2 rabbits with 1 shot would be more understandable for you. 一石二鳥? But if you are not familiar with German or Russian, you would have to try and extract the meaning of these sentences out of the context. The idiomatic way of saying this is in English is, of course, to kill 2 birds with 1 stone. The point is, using the correct idiom in English makes sure everyone understands the meaning without thinking about it. If you speak idiomatically, you force people to think about the wording you are using, and not the argument you are making. Writing idiomatic code is similar. It's easier to maintain for others since it sticks to certain rules and conventions, which are what the designers of the language has in mind. Your code is typically only reviewed when it doesn't work, either because a feature is missing and someone wants to extend it, or because it has a bug. making it easier for others to read and understand your code is generally a good idea. We saw before that the worst compiler can give you some advice on idiomatic code. For instance, when we prefix a variable that we were not using with an underscore, my advice is not ignore compiler warnings. Your final code should always compile without warnings. In this tutorial, though, we are sometimes adding functionally a bit ahead of time, which will cause us to complain about an unreachable code. This is usually fixed a step or two later. Let's start this chapter by making our code a bit more idiomatic.洗濯機の音が鳴ってた。はい。ちょっと待ってね。はい、お待たせしました。In the previous steps, we have worked directly on bytes, which was both fun and valuable. However, at a certain point, you should ask yourself, is the functional you are implementing could not be replaced by library functions, as in many cases, someone else has already solved your problem, and probably better. For me, handling with bit operations is a huge red flag that tells me that I am probably too deep down the rabbit hole. Fortunately for us, our dependency terminal makes this already a lot easier, as it can always group individual bytes to key place and pass them to us. Let's implement this. まず、to control byte を殺します。いや、その前に、まず、バイト列で比較するんじゃなくて、キーズで比較するようにします。クイックフィックス。いや、これじゃない。クイックフィックスで、タームリード。いや、イベントが欲しい。ターミオのイベントの、いや、タームリードは必要。で、マッチのキーの OK のキーで、で、キーからキーのじゃあC さらにマッチをさせないといけない。if で、ここで、キーのコントロール Q からはブレイク。で、プリント LN のキー。で、これが B じゃなくて C になると。C as U8。C as U8。で、分かってないのは、ここまで書いて分かってないのは、これが、バイトじゃなくてキーを読み込むようにしました。で、キーごとでやっていくんですけど、で、このキーズ、で、トゥーコントロールはいらないので消します。で、インプットターミオンのインプットタームリードをここで使ってます。こいつはこれで読み込まれてる。で、あっちのキーのキーチャーで C が is コントロール。で、プリント。 キーコントロール、キーチャー。これシーズコントロールって必要なのやっぱり。これ必要なのか。We are now working with keys instead of bytes. With this, that's changing. We were able to get rid of manually checking if control. If control has been pressed as all keys are now properly handled for us. Terminal provides us with values. あ、そっか、それは必要か。だってさ、これは絶対出てくるからさ。あ、これ R 書いてねえからダメですね。で、リードはいらんから消しといて。ああ、やっぱり。We are now working with keys. Terminal provides us with values which represent keys. Key C represents single character placing. Key control C represents all characters placed together with control. Key Alt C represents all characters pressed together with Alt R also. Versus mainly interested in characters and contribute to some subtle difference in the inner match key chassis. Any character and binds it to variable bit C. ね、待てよ。Before that change, we were working with bytes which we converted to characters in order to print them out. Now terminal hands us characters, so in order to print out the bytes value, we use C as U8 for the conversion. We have also added another case to our inner match, and that is special case. The case underscore is called for every case. はい。Matches need to be exhaustive. はい。We also exhaustive. So every possible match we also had to import a few things to make our cards into robot type. はい。リファクトの作成のユーズキー。 separates code into multiple files. It's idiomatic.疲れね。コーヒー飲むか。うん。結構チャプター3だけクソ長。Separates the code into multiple files. It's idiomatic. That's the main method itself does not do much more than providing the entry point for the app. This is the same in many programming languages, and Rust is no exception. We want the code to be placed where it makes sense, so that it's easier to locate and maintain code right there. There are most benefits as well, which I will explain when we encounter them. The code we have is too low level for now. We have to understand the whole code to understand that, in essence, it simply echoes any pressed key to the user and quotes a control Q is being pressed. Let's improve this code by creating a code representation of our editor. Let's start with a new file, pub3, source editor. Editor.ls public struct editor. A struct is a collection of variables and eventually functions which are grouped together to form a meaningful entity. In our case, the editor. It's not very meaningful yet, but we'll get to that. The pub keyword we want to use is a struct can be accessed from outside the editor.ls. We want to use it from main, so we use pub. This is only the next advantage of separating our code. We can make sure that certain functions are only called internally, which we expose others to other parts of the system. Now, our editor needs some functionality. Let's provide it with a null function, like this. Example. Editor. 1 and sub。で、ここでもタイが必要なので、このまんまか。まあ、要は、メインにあったやつをエディターに移しましたというだけの話ですね。Let's focus on what's new. The input block contains function definition which can be called on the select. We'll see how this works in a second. The function gets the pub keyword, so we can call it from the outset, and the lam function accesses parameter code and self, which will contain a reference to the select it was called papa. The and before self indicates that we are dealing with the reference. This is equivalent to having a function outside the input box which accepts and editor as the first parameter. As you can see, we have removed nearly everything from the main.rs. We are creating a new instance of editor and we call run and on it. If you run the code now, you should see that it works just fine. Now let's make the last remaining lines of the main bit better. Structs allows us to group variable, but for now, our struct is empty. It does not contain any variables. As soon as we start adding things to the struct, we have to set all the fields as soon as we create a new editor. This means that for every new entry in editor, we have to go back to the main and change the line let editor equal editor editor to set the new field values. That is not great. So let's refactor that. Mo fun default and self to self, not self. Editor and not semicolon. So, but editor default. We have now created a new function called default, which constructs a new editor for us. Note that the one line in default does not contain the keyword return, and it does not end with a semicolon. Last treats the result of the last line in a function as its output, and by omitting semicolon, we are telling us that we are interested in the value of that line, and not only in executing it. Play around with that, adding the semicolon and seeing what happens. Unlike run and default is not called on an already existing editor instance. This is indicated by the missing answer parameter in the function signature of default. This is called a static method, and these are called by kilogram as follows. Now we can leave the main.rs alone with while we focus on the editor.rs. And これをどういうスパレットとりあえず動作確認。これで動くかな、そうそう。It looks like you are writing a program. Would you like help? Let's conclude our detour towards an idiomatic code by using another very useful feature, Creepy. Creepy is both an annoying Windows 95 feature and a mechanism to point out possible improvement in our code. You can run it from the command line by executing it. Cargo Creepy. Cargo Creepy is not installed. What? Last up component and Creepy. Cargo Creepy. Running a Creepy now does not produce a reward. Our code is good enough to pass Creepy's default flag. However, that's not good enough for us. We want Creepy to annoy us so that we can learn from it. First, we run cargo clean as Creepy only creates output during the compilation. And as we saw earlier, cargo only compiles change flag. Cargo clean, cargo Creepy, Creepy, Atlantic. What? セルフ使ってないよって怒られたね。あ、なんか関係ねえだろ。使わねえもん、今。Not only does Creepy point out the weakness in our code, it also provides a link to the documentation so that we can read all about that error. That's great. We can tell Creepy which flags we want to be used by default. For instance, by adding code to our main.rs. Let's do that. Do this and so fix. The pedantic setting is very variable for beginners, as we don't know yet how to write code idiomatically. We need someone at our side who points out how things could be done better. Separate reading from evaluating. Let's make a function for key plus reading and another function for mapping key presses to editor operation. We'll also stop printing out key presses at this point. Please. Let's make a function for key press reading and another function for mapping key presses to editor operations. We'll also stop printing out key presses at this point. Editor でまずペットのプレスするキーが いや、疲れたからやめるか。いや、結構難しそう、ここ。ここはちょっと難しい。セパレートリーディングフロムエバリエーティングはちょっときつそうだからやめる。終わり。配信終了です。お疲れ様でした。